Another kind of strange project today. If you go looking for electronically controlled valves, you'll find these motorized ones. I must have purchased one at some point, but I never used it, and for some reason I bought a normally open one instead of what most people would think of, which is a normally closed. In other words, while it's just sitting there, the valve is closed, and when you decide to energize it, it opens up. Anyway, one thing that's pretty cool about these motorized valves is that they don't use much energy in what you might call the steady state. That is, they use energy when changing from open to closed or vice versa, but not while open or not while closed. This is very different from like a solenoid valve, which is the typical valve you might use for watering your yard or plants. These require energy as long as they are open. The energy is powering a coil that retracts a diaphragm to allow water to flow, and as soon as you stop the energy, the diaphragm snaps shut again. Okay, so why am I talking about this? Well, I have my normally open valve, but I really wanted a normally closed one, so I thought there should be a way to change it. And if nothing else, it's good reason to take something apart. The first thing I did was remove the plumbing part from the motor part. It's really such a shame, because if on this motor part they had simply put in another cross hatch through there, then I could have just turned it 90 degrees and I'd be good to go. But they didn't, so now it's time to open up the motor part. So the piece to watch is this little thing here as it rotates 90 degrees. And after that piece has swept through 90 degrees, you'll see it closes this switch. And then as soon as I unplug it, it reverses the process and sweeps back and closes a different switch. So my current theory is that the motor and gears will happily go in whatever direction you indicate. It'll just stop when those switches close. I didn't really end up using this, but I thought I might want to know the voltage to the motor, so I measured it while it was running, and it was about 4.5 volts in one direction, and then the switch stops it, and then it reverses the polarity, and it's about 4.5 volts in the other direction. So the solution I ended up with was to 3D print this plastic sweep, but 90 degrees rotated. Here you can see the original part, and then here you can see the one I 3D printed and how it's 90 degrees rotated counterclockwise. So I've sped this up, but you'll see it goes through the same 90 degree rotation here, or if you want to see it from the other side, here's what it looks like from the bottom. And just as before, when it's plugged in and energized, it goes in one direction, and when you deprive it of power, it goes back in the other direction. And I'm sure it does that by storing up some energy in a capacitor, and then it just uses that stored energy to reverse the motor back to its original position. So after all that, it was just a matter of putting the housing back together again, and of course attaching the plumbing to the bottom. It's just 4 screws on the top and 4 screws on the bottom. I did a quick test in between. So there you have it. It's a little bit about how one of these motorized water valves work. I hope this helps you.